Welcome to the third part in the predictive analytics regression and classification course. So today we are going to discuss in this particular video that how to estimate betas of that we discussed in part A and part B, the betas of the regression line using least square method in Python. So what I'm going to do, I'm going to open my Conda navigation, and then from there I will launch the Jupyter notebook. In the Jupyter notebook I will go to the lecture 1 of my things, and in this folder I have both the Jupyter notebook ready and as well as the empty cars as a CSV file is there. So both the files are there, so data file and the notebook is there. So here is the lecture 1. The objective of this exercise is basically to figure out using Python how OLS estimation for regression model works in regression. So first what I have to do, that I have to import pandas and numpy. So pandas as pd, import numpy as np. Now I'm just going to run this guy, and then in df equal to pd dot read underscore csv, and within quote unquote empty cars dot csv is going to read the empty cars data, has read the empty cars data set. So I'm just going to run the head. So you can see it has printed the first 5 lines, miles per gallon, cylinder, displacement, horsepower, all these lines. And then if I just want to read the number of samples that it has 32 samples. If I read that as a df, so remember that df is the one data frame, and in this data frame, if I just give me the shape and the first object of the shape, then it will give me the sample size or the number of rows. If I give 1, then it will give you the number of columns. See, there are 11 columns, but for the time being, now we will just in the variable n, we want to keep number of rows or the number of samples. So now we are going to define the target variable or the response variable mpg. So we define it as a matrix of order n cross 1. So df, we are going to take the df. From the df, we are going to take mpg and read that as matrix. np dot as matrix will read it as a matrix, and then typically it gives like this kind of format, so we need to transpose it, and so that's why I'm using np dot transpose, and then I'm putting it in the y variable. So then you can see that the first 4 variable I'm showing you here, 21, 22.8, 21.4, it's here, but overall it's a vector of size 32 cross 1. Next, I'm going to fit this miles per gallon as a function of horsepower, weight, and displacement. So the model that I want to fit is mpg equal to beta naught plus beta 1 horsepower plus beta 2 weight plus beta 3 displacement plus a error term, sometimes it's called white noise. So first what I have to do, I have to define intercept terms. For that, what I will do is I'll just going to define a intercept So I am saying that, okay, you just create a vector of ones and then put it in a data frame. Okay, so you can see it has created a vector of ones and put everything in a data frame. Then from data frame, I'm just going to pick these three variables: horsepower, weight, and displacement, and put them as a XDF. And then I'm taking intercept and XDF, join them as a data frame. So now you can see the first column stands for intercept, all ones, and then horsepower, weight, and displacement. And this particular data frame is ready to read as my design matrix X, and all I'm just doing np dot as matrix in XDF, and that will be my design matrix X. So I'm going to run this guy. So now you can see the same data frame has read as matrix, and I'm just showing here the first 5 rows of the matrix. It is actually a 32 cross 32 rows and 1 2 3 4 columns. So it's a matrix of size 32 cross 4. Then what I'm going to do, I'm going to calculate take the transpose of this matrix as xt, and then I'm going to calculate x transpose x. So here x transpose x is a 4 cross 4 matrix. So x is a 32 cross 4. So x transpose will be 4 cross 32. So x transpose x will be 4 cross 4 matrix. So my x transpose x is 4 cross 4 matrix. Then I'm going to take the inverse of that matrix, x transpose, and calculate x transpose x inverse. Okay, and then what I'm going to do is, let me just calculate that. So x transpose cross x underscore inverse has this x transpose x inverse. In fact, you can print it. It should not be a very difficult thing. Let me run it once more, and you can see this is the x transpose x inverse. Now remember that from my previous lectures of part A and part B, previous part, that beta hat is x transpose x inverse x transpose y. So now I have calculated x transpose x inverse. Then I just have to multiply it x transpose and y. That will give me the beta hat. So if we do that, so now you can see this is my beta hat. Now I'm just rounding it off to 4 decimal place, this beta hat, to just so that 3.71055 negative 3. So this will be, so this is actually 37.1055. This is 0.00312. This is negative 3.8, and this is negative 0.0009. So this is how you generally the beta hat estimation happens. But when going forward, we are not going to implement every time like x transpose x inverse and all then this will be a little bit cumbersome. So what we are going to do, we are going to implement this OLS estimation using the statsmodels package in Python. So we are going to implement load the statsmodels.api package as SM. So I'm going to run this, and then from SM we are going to call OLS and provide the y vector and the x matrix, and then just I'm calling fit. It works just like the and very intuitively you can work with this, and then fit the model, and then from the model you call the summary. It will give you all the necessary summary for this thing. Now you look at there are a lot of summary is being provided by statsmodels. In today's class, we will not be able to discuss all the elements of this summary, but over the next, 3 months, we are going to learn all the summary of the regression models. So, today we are going to discuss only the coefficient. Now, coefficient first constant or the intercept is 37.1055. Now, if you go back, and this is, you can see that it is 37.1055 indeed. Then, if you look into the second one, it is negative 0.0312. And if you look into this, it is indeed negative 0.0312. Then if you look into the third one, negative 3.8009, so this is negative 3.8099. Now we go back, it is indeed negative 3.8009, because e to the power 00, it's just 1 basically. And then last one is negative, after 40 there is a 9, and you can see in the fourth place after 3 zeros there is a 9, and yeah, it is here, it is also after 3 zeros in the fourth place there will be a 9 after decimal. So you can see that OLS estimation that we did, analytically we solved that analytics OLS estimation that is already provided in the statsmodel package. So we can just simply call statsmodel package and work with it. Here is a self-learning exercise. It is not for grading. You should try for yourself. Now in Python, sklearn is a very popular package. In sklearn also, you can fit OLS method for a simple linear regression models. So your job is to implement OLS method using sklearn package of Python. So try yourself and check if the coefficient values are indeed matching with these numbers. If your coefficient values from the sklearn are indeed matching with these numbers, that means you have done it correctly. But if it is not matching with these numbers, then you have not done it correctly. You must have made some mistakes. So try yourself. Good luck. In the next video, we are going to discuss how to implement the same things using R. Take care. Bye.